Interesting. All right. Welcome to today's stream. My name's Fraser Sharp. I'm not completely with it as usual, but hey ho, we don't mind, do we? Let's say hello to everybody, shall we? It's this keyboard. Hello. There we go. So our start time is whatever it says on there, 11:44. Wow, we're late today. Okay. And hello to those people tuning in. Look what we got. What have we got? What have we got? Yeah. Mesh loader complete is what we did on Sunday. And we got to just doing the constructors for the mesh. So yesterday I put in a little draw thingy to draw elements and a little load to graphics card here. Standard one. Just using two buffers. Vertex buffer object for the vertices and an index buffer as well, so we could draw elements. Don't need that many spaces there. There we go. We do need to expand upon this because look, we've got tons missing here. That's what I want to concentrate on today, is the load mesh. So first things first, let's go over the system. So the system starts at here with you coming along and doing your main. Okay, so the main is a core engine. It's going to be a new core engine, and it's going to be called something. Test game, whatever the next file is called, that's the file. Okay, for whatever you're doing. Create a window, and then you start the engine. Pretty simple stuff, nothing stupid, and it tells you on screen exactly what these are: desired frame rate, width, height, and title. There you go. It's even very kept. It's nice. I don't believe that my flint's just gone. That's going to be fun. So as stated, our test game is called test game. So let's open that. And what I've got is a triangle, funnily enough. Which is half a square, if you really want to know. Literally half a square. The indices, we get our mesh, we make a new mesh, and we send it the vertices and indices. We then add our object test mesh to the game. There we go. Obviously, we're going to have materials, we're going to have mesh rendering, we're going to have game objects. I don't know if it's mesh rendering or components. Yeah, with components and a transform. Yeah. So that's the kind of ideas I've had in here. When we add it to the base game, because test game extends core base game. So core base game, add object. I've had to add another one for testing because I haven't got the code for that one yet. So when it comes in, all I'm doing is taking the mesh and putting it equal to the mesh in here. Alright, and that's all the base game's doing. It's just storing the mesh at the moment. It will have a game root at some time. I've decided upon that. Get root object is already complete. Right, so that's it. That's all it does. So if we go back to main, we get our core engine and then engine start. So we've initialized our mesh, and now we get to start the engine. Start your engines. So this is the core engine. Okay, this is your main loop, in other words. I've put a FPS counter in there. So normally it would do render using the render engine, but at the moment I don't have a render engine, so mgame render. So it goes back to our game, which has been initialized here. Okay. Game render. So let's go back to our game render. Here we go, mesh test only. That's the add, that's the render, mesh draw. And that's the end of it, really. We're back to here, which gives us mesh draw, and that just draws it all up. Okay, so we've used load to GFX and everything. When we decided upon our mesh and we transferred in, we did load to GFX vertices, indices, calc normals. Which just creates a couple of the two buffers that we need. Right, okay. Do we need any of this explaining, do you think? I mean, it's a standard GL that I've been using before for GL draw elements. It's exactly the same load to GFX I've used before, except I just run it down the page instead of splitting it into like 3 or 4 methods, which I could do, but I'm only using one buffer. I'm not using multiple buffers. There's only going to be a vertex buffer and an index buffer maximum. So this may need altering. Yes, it will. We'll need the other pointers, and we will need the strides. That's for definite. We'll have to fix all of that. So the final version will definitely have strides and a lot more vertex attributes. So that's good. So this will be expanded upon. And everything will just be in the vertex data here. And we just do a list of those. That's good because it's a VAO. Right. If we run it, it works, and our FPS counter is at 60, which we said we wanted it at. I could probably put 5,000 in there and it wouldn't matter. So let's run through the main loop, what I've got of it so far. And the main loop is in Core Engine. So the Core Engine, the main loop. Right, we're starting off with the game, a render engine, which we haven't done yet. We're having the width and the height of the screen. That will come in later when we need the aspect ratio. Frame time. So, public core engine takes in a game and a desired frame rate. The game and the desired frame rate is saved. So M frame time is your desired frame rate. We create a window very easily by create display. Why have I got Vulkan here? Stupid thing. Rendering window, if you remember. Good old window, I'll take you through that in a minute. So we create the window. That saves out the width and the height that we can use later for the aspect ratio. And then we give it a new rendering engine. We start it by initializing, well, there's initialization of stuff probably to go in there, but I don't know yet. So that's why I've got start and run as separate. Run is private. So when we run, yes, we haven't finished it. We initialize frames, frame counter, last time, and unprocessed time. So this is how we're doing our frames and our frame counter. We initialize the game. So we run init, which is there. That's our test game, yeah. So we run all this lot. Alright, that's where it comes from. And while the display is open, that comes from Window 3D. What display is open? It's, if you hover over it, it's rendering.window3D. We make renderer equal to false in case we don't get time to render. In other words, we have to skip a frame because it's running too slow. Start time, get time. Oh yeah, I found out how to get time now. Let's have a look at that. Look at that. The whole of the time class is get time. It defines 1 second as in nanoseconds, and all it does is return the system nanotime divided by a second, which is 1,000 million in English. Yeah, it's small. So we can get time. The delta time is the start time minus the last time, obvious. Last time then has to pick up the start time for the next loop around. Unprocessed time, we just add delta time to. Starts at 0. Frame counter equals plus delta time. Am I counting frames here? Yes, frames is 0, yeah. So, get into the big while loop. While do. End of while loop there. So this is a while loop as it stands at the moment. We turn render to true if the unprocessed time is greater than frame time. Then we've got time to render. Otherwise we haven't. We'll just go to the next frame. Very clever stuff. In other words, we skip a frame until we have time to render. We do unprocessed time. We take the frame time off it. Then we do the game input. No idea how. Oh yes, I do. I don't know if I've done it though. Oh, it's on a callback, isn't it? Oh, there's no point in trying that. Never mind. Throw that away. Have some coffee. Game input isn't up and running yet. Game update. Delta time again. Sorry, frame time. If the frame time counter is greater than 1, then we print out how many frames have gone by. That's our FPS. We then carry on doing that until that is no longer true. And that's the end of that. So if rendering has been caught is true, then we just render. Updated display, in other words, swap the frame buffers. Poll for events, because I'm on a callback for the keyboard. Else, if we can't render, then just sleep for a millisecond. Or sorry, yeah, it's a millisecond that I think. For the shortest amount of period of time as we want to, right? And then it's on a try catch, clean up. Once everything's finished up and it drops out of the main loop, which starts there. The main while loop is that one. That's the inner while loop. That's the end of the main while loop. If we come out of the main while loop, in other words, the display is closed, we do clean up, which at the moment is just close display. Destroys the display, that thing. And to test it works, I'm going to hit the escape key. Escape key, it works. Right. Lovely. So that's everything. That's what I was doing yesterday, was just starting to pad out and work out what I wanted to do. So we now have 17 to-do items. Yeah, they climbed up a lot. Right, so back in the mesh class. The next thing I want to do is load a mesh. At the moment it doesn't. So let's see if we can do this. This is going to be fun. I'm going to need some ideas, people. Anybody got any help? Did anybody watch on Sunday? Ah dear, right, where are my notes? Got some notes here somewhere. Yeah, notes on how I want to load a mesh. This is going to look completely screwified. Alright. Loading a mesh shouldn't be too hard. By the looks of the notes anyway. So to do, mesh loader. Let's start this one. I am going to go for the finals, aren't I? So we're going to need a string. And you know what this is all about, splitting arrays and stuff. No, I don't want to do this. No, this is what I decided against, wasn't it, yesterday? How did I do it last time? I just made a string for the path, didn't I? Well, I can't see why we should do it any different. JBlade source. Okay. I think I'm going to start this one off the same way as I started off. I've just done the loader, haven't I? No, it's not that one. It will be object loader. Yeah. So it's this bit that I'm looking at. But it's not quite the same now. Right. Let's see if I could. Yeah, now I've remembered how to do it. That's okay. OBJ. OBJ model we need. Just call it OBJ model equals a new OBJ model. And this is where we have to put in our thingy, isn't it? Yeah, our file name. So it's going to be I think it was just res slash obj slash plus file name, and then plus .obj. I think that's what we did. Yeah, got it right. So I'll take our file name, whatever we call it, and that will make an OBJ model. And the OBJ model we did on Sunday, so look at the previous stream for that one. I'm not going through that lot again. That should hopefully create everything that we need. We will need our index model. Can just call this one model, really. No, model equals obj model dot to index model. Correct? Yeah, I'm thinking that looks good. And now we can make the big buffer. Because we're only having one. You can see how this is working now, I'm hoping. Let's have an array list anyway. Let's have it, because this is how we're going to do the buffering, isn't it? An array list of vertex, because we've already done the vertex object, which is good. That's going to be vertices equals a new array list, believe it or not. Do you think? I think that's right. Alright. 4. We have to go through them all now. We have to go through everything, don't we? Int. I'm going to use I equals 0, semicolon, I is less than our model dot number of vertices, please. And we'll just dot the size on that, because we don't know how many there are. I++. Do that. That looks good. And we need to start filling everything up, don't we? Remember, there's only one buffer. So it's going to be vertices. So this is going to look absolutely huge. Add. Dot. Let's go back in there. What we're going to add. These are in Vex. So this is going to be a lot easier. Model dot I want the vertices first. Dot I comma model, what do we want next? Texture coordinates, I think we'll have. Model dot texture UVs. Yeah. Dot get I See how much easier this is than it was before. Model, what do we want after that one? Normals next. Yeah, model. Get normals. Dot get I. Comma. We're just making one massive big buffer of stuff. Vertices. Vertexes. See? Vec3, Vec2, Vec3, Vec3. So we're just literally lumping them out of there. Out of the model. All of our stored data. Using that index thingy. So model dot we've done normals, so it's just tangents left, isn't it? Do tangents as the last thing. Dot get I. That should be it. Can I resolve method add? Well, it should be adding a single vertex. What did I call it then? Ah. Do we not have the tangents? Okay, so we've got vertex texture, vertex texture normal, vertex texture normal tangent. You know what I've forgotten, don't you? You know what I've forgotten. There we go, it's now coming up properly. Doesn't look right. No, it looks right. Thank you. Yes, we have to add a new vertex. So I've already done that. Thought for a minute we hadn't. Good God. We're not in the for loop anymore. Let's get outside that for loop. We've done our for loop. That'll do. Right, so vertex. Do blah. Array. A vertex array will be our vertex data. Remember, we don't know how much there is, so we have to put it into an array list first. Yes, lovely. That's going to be a new vertex. And that's vertices dot size. That'll do. Yep. Vertices. I don't know if this works or not. I've got a note here that says that this will work. To array. Oh, you beaut. No, I haven't got that in C++, unless you write it yourself. Okay. We need our index data. We can take that straight from the indexed model, which is model. So I'm going to use the same trick of what I've just done, aren't I? So integer array index data equals a new integer open brackets, and it's in the model dot, the one that we haven't done so far is that one, and we'll need size on that. Yeah, that's right. So that'll get that, that'll make that the correct size, and then all we need to do is add a space, model dot get those indices. Where are they? Put them to array. And it's going to be just index data. That places them in that array. So now we've got all of our data in vertex data and index data, the two big blobs of information I wanted. Which means we can send that into here, because we've got the vertices array, the indices array, and what about calcing normals? That's false, isn't it? Because we're supposed to have actually read them in. That's going to be interesting. Alright, well, for now, we'll do it the simple way. I don't like what I'm doing, actually. Vertex data, comma, index data. Isn't it simple? Comma. I'm thinking that, but my mind's saying something else. What's wrong with my index data? Really? Damn. Damn. All hooked up except for the indices. Sorry, I'm just reading my notes. We can do it a different way. Yes, okay. Control Z. Index data ain't gonna fit, so take you out for a second. We can use a utility, can't we? Util dot to int array. We don't have it. Looks like we're going to have to write something then, doesn't it? Yeah, we are. Where should we write it though? Pop it in here. Oh, I've written the create vertex buffer. I had to, for the testing, I had to remove like all of textures normal, but you can see it's all in one big blob. Yeah, it's okay. Right. I'm just going to write a small little function here, I think. Public. Well, this is how this has worked so far. As we need it, we write it. Int. Public static int is the return value. And we're going to call it 2 int array. And we're taking in an integer array data. There we go. This should do it. So we'll need a result. Int result equals a new int of data length. That should do that. And then we just need to go through them all and just pop them across, I think. Int I equals 0 as long as I is less than the data length. I++, simple kinds of stuff going on here. All we're going to do is take result I that's just going to equal data I its counterpart, but I want the int value, please. Perfect. That'll work. Return result. Now why doesn't it like that? Pardon? Okay, Muppet, you're moving. There is that speaker's back. It's not. I don't like it. I'll sort this bit out after. On clean up. I want my int value in. Thank you. Want to make sure it works first. So we now have 2 int array data. Okay. That's what I wanted. Does that look good? And then we just put in index data. Yes, we have success. Wow. And yeah, we better return some actually. Yeek. Just return this. That'll do. So that wasn't as difficult as I thought it might be. Load mesh file name. That'll now work. We hope. That gets put through there. Load to GFX is a void with no return value. Okay. Look at my data path from the last time. That should be okay. We have a new data path. But now it's got a massive problem that it's got everything else in it. Because we're using a single buffer. Okay. I need the full buffer conversion. Right, so that's a full buffer conversion. And our vertex will now comprise of 11 items. Right, that's its final value. If you're wondering why it's 3, 4, 5, 6, 7, 8, 9, 10, 11, just add them up. There's going to be three vertices, 2 textures, 3 normals and 3 tangents. That equals 11 items in there. This now becomes important, as we are about to find out in our mesh. So our load mesh is good. I like that. Calc normals is false for the moment because we haven't got anything to do. We haven't got resource management, so that's okay. So this part is load to GFX, isn't it? Okay, let's have a look at this. So, we are creating a VAO. We are then creating a VBO. And now we want to put our data to it. Is that all it asks for? Yeah, it is. And now we have all of these to do. We are going to need a few more of these. Yeah. Oh, wait a minute, I just do that, don't I? I'm going to press Ctrl-D. Yeah. So, we've got 4, haven't we? Oh. 1, textures, normals, tangents. Okay, so that means we're going to need another 3 of these. One, 2, 3. Yep. So the index is now going to be O, 1. The beauty of working with one buffer. 3. Remember, this is all being recorded by the VAO, so we don't need to change that code. Now our stride is completely out. The next item, it isn't going to be sequential. It's going to have stride. So our pointers are going to change. And the second one, that is going to be 2, because that's your textures. So the size is only 2 vertices. So stride is going to be vertex, that variable that I just changed, vertex size, which now equals 11, and we just have to times that by the size of a float. Yeah. That's the stride. It's the actual size of a whole vertex. In other words, 11 items of data in bytes is times 4 for the size of a float, so it needs that stride in bytes. And it's the same for each one. It's the offsets that'll change. What they call the pointer is the offset. Right, so the first offset is going to be 0, because that's at the start. The next offset is going to be that many into the buffer, and that's 12. So I've got 3 times 4 is 12. We've now got 12 plus 2 times 4, which should be 20. Plus 3 times 4 is 32. Oh, disappeared on me. Thank you. So that's our strides and pointers into the buffer. All done. We do enable index buffer stays the same. We don't have a shader yet. I'm dreading testing this out. But we've got to. To get to load mesh, we have to put in mesh string file name. Okay. Wait a minute, let's just see if that runs still. It does. So the code's not crashing. Wow, that's interesting. Don't trust that, it shouldn't have worked. Oh, it's because it's it's only simple. It's because it's only a triangle. If I try and put a second triangle on now, I bet it won't work. Well, maybe it will. Right, I'm going to test that first then. Alright, I'll have a new vertex. Which will be a new vec3. What should we have for the values? I want the top right hand corner. So that will be 0.5. That didn't work. Numlock 0.5f, comma, top right 0.5f, comma, 0.0f. There we go. Make sure I haven't got that vertice. No, I haven't. So currently it goes from top, down, across. So now I want it to go across, up, repeat the first one. Which is comma 2, comma 3, comma 0. No, didn't work. I didn't think it would. I don't think it's got all the other values. So I think the values will be getting screwed up in there. They're probably going into the textures or something. So yeah, it'll only work for a simple. A simple thing. It won't work for anything else because of our values. Okay. Alright. Fair enough. And just going OBJ model test. Of course. Come back. Thank you. Run that. Oof, nice one. Thank God for that. I thought I'd done it right for a minute. That would have been embarrassing. Alright, so it's relaxation and debug time. don't think it should be able to work from this position anyway. But we shall find out. It's usually the size of the arrays and stuff that are a bit of a problem. It's not going to have tangents. No, I did do the tangents, didn't I? Yes, I did. God, how can I forget that? That was awkward. At least it's running the code. That's something. File reader. OBJ model 35. Oh, it's one of ours. We checked for something. That's why I always put an exit code of 99 on it, so I know it's mine. So it's decided that it didn't like it. The model, that is. So that was on OBJ model 35. It's the file reader. Returned an error. Need flints. I haven't got any here. Oh, you know why? I've done this twice. I've done that in Mesh as well, haven't I? Yeah. That doesn't help. If you do it twice. Let's try again. Blow me down, it works. Oh my god. You can't see the model. Why? Because we're inside it. And I bet I've got cull backface going. Didn't take you through the window, but it's the same window that I always use, so. Should go black. Or red. It's working. I don't know how much of it is working, but it's working. Without a shader, I can't move it. Without a transform, I can't move it to find out. Or can I? I can go back to -1. And then it'll, or -0.9, and then it'll fail. But I've got no way of doing that. I've got no matrices. So I know it's working. Good. Test complete. It is working. It's actually drawing what we told it to draw. It's just that I know what we told it to draw, which is a box that we're inside because we haven't got a camera and we haven't got shaders and we haven't got matrices for model location. How much more of this have we got to go through now? I think the draw routine's okay. Bind the array buffer, the vertex array, sorry. Draw the elements, and then unbind it. Yeah. That's all I need to do. For now, that's all we've got. GL clear shouldn't be there. It should be in the render engine. So I think box to you. Came up red as well, interestingly. Doesn't worry me yet, because it'll be all over the place until we sort them out in a shader. Do we need anything else in here to get to? Yeah, the calc normals. I think we should finish this off before I carry on. Data size, hold on a minute. Is that true? Is that true? $24. No, it's not. Yes, it is, isn't it? $24 indices. There are 5. How many faces? How many faces? That's the answer, isn't it? So it's 5 times 2, 10, plus 4, 14, not 24. I think it's indices length. Let's try it out. Let's try that one out. Ah, wrong button. Just press escape. I can. Yes. Ant, come here. 36. So I've got 36 indices, which sounds a lot better. I think we might go with that. I'm feeling better about that, so we'll go with indices. Oops, can't do that. Whoops. Alright, close you down now, thank you. $36. How do I get to 36? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 3. Yeah, it's 36. Whereas vertices, we've got 1, 2, 3, 4, 5, 6, 7, 8 times 3 is 24. Well, if we're drawing elements, we want to be drawing the index buffer. And the index buffer will probably get us further, depending whether we've got these faces or not. Okay. I'm happy with that, up to a point. All right. Calculate normals. Now, first of all, my booleans seem to be all over the place. Here, we set them to false. But OBJ model has textures, has normals. Final value of that is more interesting to me than anything else. Okay. OBJ model. So it's in OBJ model, which is OBJ model here. We don't have it. What can I do? Public Boolean. Will this work? Well, it'll be the reverse. Yeah. Public bool get has textures. No, it's normals that we're doing. And all we're going to do is return underscore has normals. Keyboard's giving up. Come on, keyboard, come back to life. Thank you. Right. Get has normals will come back true, so I want false to calculate the normals. Yeah, that makes sense. Which means back up here, this one here, vertices, indices, count normal. True or false? I placed in false. Well, without normals, you can't light something. I think that's true. No way of testing it yet. Can't decide. Okay. Alright. Calc normals, huh? Anybody any ideas? I think this is the final thing we need to do in here. Oh, except for the resource management, which I don't really care about until the end, because that's going to be a bit of an pain to do. Trying to find the right word. Right. How are we doing in chat? Anybody? Everybody happy? How do we count normals? Have I got any notes on calculating normals? God, when was the first time I did this? I learned to calculate normals nearly 26 years ago. So you'd think by now that I'd know how to do it. But I stopped using it because we're getting them from the model. But that might turn to false or true, depending whether the models will support our lighting or not. We may be recalculating the normals. I don't even think we read them in at the moment. Yes, we do. Uek. Do I have my old notes on calculating normals anywhere? Oh my god, calculating normals with using vertices and indices. Hold on a minute. Here's a simple way of doing it. I might be able to, yes. I think we're going to be good. I've got notes. And one match and no flints. Right, coffee time. As I'm now starting to get desperate. What do we want to do here? Nothing. Here. We do that. We do that. We do that. Oh, wow. Be right back. Get yourselves a coffee. We're going to calculate normals. Wow. I'm back. Hello, Akron. Hiya, mate. Good to see you. Whoa, before that gets too high. I know what it's going to do next. It's going to go bang. Ah, bless. Capture card. Yay. And we are on calculating normals. Whoopsie daisy. Calculating normals at my time of life is probably not the best thing I could do. So I'm going to need vertices and indices. What information do we have? Vertices and indices, it's just below, yeah. We might be able to do it from that. Alright, let's see, let's set the signature up first. That's going to be a vertex of vertices. And that's going to be an int of indices. Yeah? Yeah, that's the signature. Oh, we've got a sneezy cat. We've got a sneezy cat. Oh dear. We're just going to use a for loop, I think. Wish my notes were better. Oh, learning Unreal. Wow. You want to get a job with Epic Games. Alright, that's good. That's good. That's good aim. Good on you, Akron. Anything I can help with on Unreal? Unreal Engine. Not Unity. Epic Games, Unreal. Yeah. To be honest with you, Akron, I can't see why you can't get a job with them already. I don't think you really need to learn it as such, because it's the same programming, it's just how it looks on the screen. Is there a plugin for Unreal Engine on Visual Studio 2019? Yeah, portfolio would be good, yeah. Well, if you want any help with them, just shout. I mean, if you, I prefer you to work out your own solutions, but because that makes you a better programmer. But if you get yourself into a bit of a rabbit hole, let us know. Yeah, it's alright. That's what I'm here for. I'm here to help. So are you using Visual Studio for it? If you're going to do a network game or two, make them very simple. Start with something like Pong. That'll get your server going, and then go into 3D from that. Yeah. Yeah, I don't think you should have any problems at all. Let's have a look. What have I got on Unreal? Let me just get to a different screen. I haven't got a clue what I've got in Unreal. Third person, first person projects. Yeah, I'm just adding network to it. Yeah, that sounds good. So you're working inside Unreal Engine itself? Let me just find something on my stuff here. See if I've got it. There it is, Visual Studio Installer, that's what I wanted. Dooby-dooby-dum-dum. Can't read what he's saying, come here you. Get on the screen a minute. Spatial OS. Yeah, okay. Oh my god, you see what I've got installed now. Too much. I haven't got Python. Oh, I have got Python, yeah. Python 3. Which I find ironic. But anyway. So I've also got F#. Yeah. Unreal Engine installer. Thought it was here. Yeah, I've already got it. So yeah. I don't need to modify that. That's good. As long as I've got it, I'm happy. Alright. Back to what I was doing. Yeah, you can set it. You can do quite a lot of the scripting stuff in Visual Studio. I mean, what's the scripting in? Is it in C# for Unreal? Which is Java. I think it is. Or it's in a Python-like markup language. I can't remember. It's been so long since I did Unreal. So long. I mean, nowadays it'll be something completely different to what I did way back then. Excellent. I think you're on a good track there, Akram. I think you've got a good idea. I think you know what you want to do. And I think really you're approaching it the correct way, it sounds like to me. So I'm with you. I'm with you all the way on that one, mate. As I'm only a researcher, I probably couldn't get a job nowadays. No, well, the amount I can do nowadays. I can't really write that much code. I mean, I try on this stream, but my fingers just... bleh. My fingers have had it. I was going to do a for loop, wasn't I? Guess which for loop we're going to use. For int I equals 0. Semicolon I is less than. And it is indices.length. I I++. I saw it flash there, right. Yeah, it's free. Are you still a student, or are you just doing the community version? I've just got the community version. I think you'll find Visual Studio integrates better than most for Unreal. If there's one thing Microsoft has done with Visual Studio, they've made it bloody generic. Integrating it is just a case of typing in the right libraries, and I think it does it for you. I think it does an Unreal setup for you, like a basic project setup thingy, an automated one. So it'll probably set it all up for you, to be honest with you. I mean, that side of Visual Studio you could say is good. Why did that go red up there when I pressed here? That was a bit weird. A completely different function. Who knows? Control S, get saved, just in case it all crashes on me. Yeah, I think that's worth looking at. I will need 3 indexes. Because there's 3 vertices, isn't there? Yeah. For this calculation. It's the same kind of calculation that we did for tangents. So it's the same setup. It's index 0 equals, well, indices 0. Index, no, don't do that. Index 0 equals indices 0, I think, I. Run a loop. Semicolon. Control DD. 1 and 2. And I think I'll have plus or 1. Do I really want to do I++? I don't think I do. Plus 2. That's better. Plus equals 3 might do better. We're using 3 at a time. I don't know. What am I like? I need 2 vectors to do a normal. Yeah. So we'll have vec1 and vec2, I think. So these are going to be vec3s. And we'll have v1 equals vertices. It's going to be I1, index 1. Get pos, of course. Get vertice or vertex. And we'll have to sub that. Subtract. A vector 3 right. Okay, so that will be... I want index 0 for this one, don't I? So it's Why has vec 3 gone red? Oh, I'll get to that when I get to it. Vertices. Index 0. And we'll have to get the position of that. So let's get the position which is a vertex. Sub u. I think I need the word new in here somewhere. Alt plus enter. Is that all we needed? Alright. Why is that? Did we not have it? No, we did not have it. That'll do. I'll make a copy of it. Because it's basically the same, except I'm going to use v2 instead. Be original vector 1 and vector 2. This is going to be index 2. We have to go back to the same place, don't we? Yeah, we need a specific origin. So index 0 is our origin, index 1 is our first vector, and index 2 is our second vector to that origin. And then we just need to calculate the normal between them, and that's a cross product, if I remember my gaming programming right. And we will want v1 cross product of v2. Yeah, I've added a couple more. C for cross products. I'll put it up here. Sure. How are we going to do the cross product? It's not usually too difficult to do those. Have I got the formula here? I might have. I have. Fantastic. Thank God for that. I was going to look it up on the internet for a minute, just to make sure I was right. Vec3 returns a vec3. We'll just call it cross. We should really call it cross product. So I will. And we'll take in a vec3 right. Yeah, that'll do it. It's a good start. And we are going to return a new vec3 comprised of A, B, and C, whatever we calculate. Yeah, that'll do. That will do nicely. So we'll need 3 floats now. Float A, B, and C. Okay, cross product time, peeps. Let me know how that goes along, Akron, by the way. If you think Visual Studio is hard to set up or not. Because what I'll do, whilst off air, I'm not doing it on air, is I'll have a quick look. I haven't got a clue where my notes are for Unreal, but I can start digging stuff out. Yeah, and it's probably way out of date, so I'm going to have to compare it to what's going on in today's world. That's going to equal... We want the cross product, don't we? So it's my starts as... We'll start with y. times right dot get x no, y goes to z. Yeah, y goes to z, and then you have to remove z and y. Yeah, right. Dot get y. That one. That is correct. Y times z, z times y. Y times z, z times y. Yeah, that's correct. This one equals z times x. So it's m underscore z times right. Which one? X. Get x. What do we have to take off this one? Well, it's reverse, isn't it? So it's mx. M underscore x times. Whoa, didn't get that right. Well, hey. M underscore x times right dot get z. Lovely, that looks good. And the last one is, we've done y, we've done z, this is x. M underscore x times right get y. From that, we want to minus the opposite, so it's my. Wow. I hate doing these. X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. Got it. That's it. Done. That's your cross product. Anyway, meanwhile, back in Mesh, we want to use that. To calculate our normals with. Might be a good idea. So we'll need a vec normal. And it's vector1 dot, went wrong way, cross product with vector2. Yeah. But I want them that. I want them normalized. Yeah. Vector1 cross product, vector2 normalized. That'll do me. This could be interesting. Now I have to set the normals. Let's see if I can work it out anyway. So, which vertex are we on? Let's take index 0. We want to set the normal. Good, we've got it. Open brackets, yeah, this is going to be fun. Vertices index 0. Get the normal and set it. Add it. Do something. Add. Yeah, we can just add to it, can't we? Because it'll be a 0, 0. Normal. Does that match? Got it now. Yeah, that's correct. I just realised add doesn't mean what I think it means. Oh God, that's a lowercase add. Is that on from the vectors? Yes, it is. So we are adding the vector. That's good. Lovely. And that yeah. No idea if that's going to work really. I think it does. I think that does what I want it to do. I'd have to truth lock it, wouldn't I, to find out. So index 1. No. Yes. Index 2. That's index 1. That's index 2. That's it. That'll do the for loop. We'll need another one. Don't we always need another one? Oh dear. Yes, I'm making a 3D engine backwards. God, you've got to love it. Equals 0. Whilst I is less than... Got to now put everything into the right places. Is less than vertices length. Yeah. Now I have to alter all this lot. So vertices I set normal to something, vertices I, dot get normal dot normalized. Will that work? Something wrong with that. I've got a bracket missing, haven't I? Nope. No, I'm alright. That's me setter. Done. Okay. So now when we load to GFX, we can calculate normals. Is that correct? Yes, it is. Oh, dearie me. That's one more less to do. I'll do that. Can't do new resources. I think that's now right. No more to-dos. So it's just resources there. And a check. So we can calculate normals if we pass true through. So if it doesn't find normals within the model, it will now calculate them. Unless we've reset it to false somewhere. So if you create a mesh with vertices and indices only, wouldn't you want to calculate the normals? That would pass it through to here. These are constructors, by the way. It's just got multiple constructors. One leads to the next. It's just building the constructor up. That one's a separate one. This is a separate one, but it can be built through here. If you didn't send through normals, I guess you didn't want them. That'll be an interesting test. Okay. I think that's it. I don't think those two are for test only anymore. I think I'm going to need those two. As you can see, they're not highlighted like this stuff here. So I'm going to take that off. And I think our mesh class is complete. Yes, it is. So now we need a shader. Oh, it's Muppet. Wow. Muppet's on one. He's gonna sneeze. He's gonna sneeze. Duck, everybody. I'm actually now quite interested in that Unreal thing. It's my own fault. I am nosy. Well, not nosy, but I just love ideas popping up. Okay, whatever. Alright, so what have we done here? We've done mesh. Load, construct, mesh, draw. I haven't done resources. So we haven't done mesh resources. We've got the index model, the object, yeah. We've got all of that. Rendering, resource. We'll need the mapped values, the shader resources, the texture resources. Okay. Over on the left hand side is now what I want to do. I've done the window and some input. It's a GLFW window, and I know that part of it's a bit dodgy, but I've still got it there. We've got vertex. So texture, shader, material. So material and texture really go together. I think that's what I'm going to focus on next, is the materials and the textures. Yeah. Where do I put them? I'm going to be using a component system. Material and texture. Where shall we put you, little babies? I'm thinking... I'm just going to stick them in here, into the rendering. Alright, let's get that saved out actually. That'll do. That'll do. I really wouldn't mind doing the transform next. Come on, mouse. I know there's supposed to be a delay because I'm using a capture card, but what's going on? Okay. No errors. Got some warnings. No. I reviewed them as I went through. Okay. So I've done the utils for the buffers, basic core engine outline, and core base engine. Mesh render test complete. Mesh filled out, just needs resources. Yes. That's a good place to be in. I've already got transform in. It's part of the core. And we're not really doing the core at the moment, are we? Oh, Muppet, love. But I am going to need that for a test. Because I have to move this goddamn thing. Otherwise we can't see it. But the next thing it says here is material. Okay, now that's got it then. Core, go away. You're not being done. Maths, go away. Rendering. We'll have a new Java class called material. Okay, yes, add please. And I'm just going to call it texture because it's going to have the loader in there, isn't it? There we go, texture, add. And those are the only two I want open, please. I think we'll start with the texture. Okay. The reason I put the to-dos in, by the way, is because I've got a very bad memory. Well, not a very bad memory. I have to operate on a blank mind. Otherwise, I'll be screaming in pain. So that's why I use the to-do system. So when I make a blank, like a construct that I want to work on next, I always put a to-do in there. And it's the same here, really, but I don't know whether I want to put it in yet. Okay, texture. We're going to have to load you, aren't we? We are going to need resources. That's a given. I can tell you that without even thinking about it. The only thing I know that I'm going to need right now is a private string file name. And that's it. That's all I can think of. Let's have a public texture to a constructor. May as well construct one, and we'll take in a string file name. It's a member variable, so I'm going to mark it as a member variable. Old habits die hard. There we go. Can we just straight load it? Yeah. I just want to load it, don't I? Oh, God. I want a ton of public stuff, won't I? So we are going to need some other variables. But here, I'm just going to have a private static. I'm not. I am. I'm not. I'm going to have a static. Load texture. String. File name. Where did my cursor go? There it is, thank you. Couldn't see it. I told you my eyesight was bad. Why do I need to pass this in? Dum dum da dum 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 dum. I'm about to do something dumb. Why do I need to pass this file name in? I've already got a file name. We've got textures. Right, okay. My standard set of textures. Yikes. Dum dum da dum 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 dum. Okay. Alright, let's see if we can get this going, shall we? We might have to write a load of functions here. Or we might be able to get away with it. Right. And it's going to throw me into a massive try-catch, isn't it? As it always does when I try and load a file. Okay. Let's just go for it and see what happens. Buffered image. We've got a buffered image. Image. Haven't we been through all of this? We've loaded a texture before. 1 second. We did it in the loader though. Here. Oh, it returns an int. Blah de blah de blah. Change it all over. Parameters. I might change the parameters. That unbinds the texture at the end of the operation, and then we just have to do whatever we need to do with it. Can I write that in a simpler way? We can ignore the alpha. No, we can't. I can swap this around and just doing it as a big one. I don't need to do too much with that. I don't think I want all of this lot in here. All this OpenGL stuff. And I can remember the rest of it, I hope. Yeah. We'll see what we need as we go along then. That looks good. That looks okay. Fantastic. Where's my coffee? Ugh. Can I simplify this? Let's see. It's got to start off like this anyway. So it's going to be the image.io thingy, isn't it? Image.io dot read, I guess. New file. Input stream. File. I'll have. So I am slightly mixing it up here. It's going to be res / textures plural, because that's what I did, / plus, I think you know what I'm doing here, file name, file name, plus obj. Because we're using a constructor, I don't need to pass the file name around. I've already got it, so I can't see why we shouldn't just use it. Looks a lot better to me. We can semicolon that one off. And there it is. I already know what you're going to say. Surround with try-catch. Thank you. Right. We've got our try-catch up. That's a good start. Slow down now. Oh god, all I can see now is a white blob of paper with all the writing on. The problems of a photographic memory. It's why I don't like white on my screens. It's why I can't work with an IDE that's white. Go to sleep and I'm blind for the evening. I can't watch TV because of it. I can't have the news replaying, it just makes me angry. Can't imagine me getting angry, can you? I think it's only happened once or twice in my life. And once was at somebody that annoyed me. And the second time I got angry was at a news broadcast. Last time I ever saw a news broadcast. That was a long time ago. So it's over 20... No, it's more than that now. Oh my god. 30 years tomorrow. 30 years tomorrow. Because tomorrow's a big day. It's a day when I get another grey hair. That was the last time I saw a news broadcast or got angry at a person. 30 years ago tomorrow. That is amazing. "30 years without being angry." Frustrated, yes. Angry, no. Alrighty. Enough of my self-reflection. Let's get some pixels. Have we got a byte buffer on this system? Of course we have. There it is. A byte buffer. We'll have one of them. No, we won't. I'm lying. Pixels are just ints. We've got an image. We can get it from here, can't we? Yeah, stuff the alphas. You know, it does get the alphas as well, doesn't it? Depth 24. Yes, it will. So we'll get that. Image dot get height times image dot get width They are floats. No, they're not. They're ints. That's still full. Size. I need bytes. This is a size I'm putting in. Really. Oh. Yeah, that should do it. No, I'm doing the complete wrong thing, aren't I? Rewind. You've got the start position, which is not. Is that a float? What does this thing want? Doesn't tell us. Okay. That's a note now. Ah, here we go. So it's int start y 0. Now I want the width. Now I want the height. Now I want an RGB array. Oh God, I hate this. I can't think of one. No, can't think of one. Offset none, and scan size is the width. Will that do it? That's what I thought. But I don't want to place it in there yet. All right. It's just a different way of doing it. Yeah, because I'm directing it back into there anyway. God, I hate this. When you can do this in... I think you can do it that way round. I'm not sure about this. I think I like this way of doing it better. That's what that would be. That would be pixels. There we go. Has the same effect. I'm going with that one. That one looks better to me. It makes more sense to me writing it that way than it does pixels equals and then putting a null a null buffer in there. Which I don't like doing. I don't like the word null. Right, we're going to need a byte buffer now. We are going to need a way to create a byte buffer as well, aren't we? And then I've got a byte array. And I need a length. Can we do it straight from the size? This I've just taken from the other utils that I had. I want to change it though. I'm not happy with what I'm looking at. I think there's a better way of doing this. Or a simpler way of doing it, should I say. Let's see if I can think of one. Buffer utils will do it. Normal buffers will do it. Hold on a minute. Let's see if I can put this command together and see whether I actually need a utility to do it or not, because that's the utility that I've got in front of me is for use in OpenGL. When you're passing it through to OpenGL. I don't want to do that, I just want to create a byte buffer. Okay. I'll just call it buffer. Equals util dot create. It's not here. Why is it not here? This is a bit dodgy. Try buffer utils. There, that one. Dot create byte buffer. Just want its capacity. Times 4. That should work. Surely. Yeah. So I don't need to create anything new. It's already there. It already works for me. Right, okay. I'm happy. Java's doing its thing. It's confusing me. Sometimes I never know whether I'm supposed to write a new one in Buffer Utils 3D, or does it already do what I want it to? And it already does what I want it to. This just creates a byte buffer. It doesn't create a byte buffer that can be used by OpenGL. That's a whole different story. Let's have a bool. I need to know if it's got alpha or not. They don't need to have. So it's image dot get color model will have it. Dot has alpha. There you go. How's about that for a command? Easy. Easy peasy. And at this point I do need a break. Have I run out of coffee? Yeah, nearly. How am I doing for matches? Not very well, okay. I'll find a drink as well. I'll only be a second. Oh, it's got a small flame. This needs gas. Give us a couple more secs. Emergency lighter created. Nice one. I am the best. And black burpy bubbly liquid. Woohoo! We got some. Get that cup out of the way. Get that out of the way. I'm about to do something stupid. We now know whether it's got an alpha or not. Okay, so we can do a for loop, and it's going to be a YX, isn't it? Yeah. An inside out for loop. For int y equals 0. Y is less than, and that's going to be the image height. Semicolon I++. Y++. Dar. And then we'll need a second one for int, and this time it's x equals 0 to x is less than image width. Yeah, x++. So that gives me xy coordinates in the image, byte by byte. So we'll get a pixel, a p, and that's going to be pixels. Oh god, combine that into y times image, which way? Width. Yeah. Image dot get width, and then we just add the x on to get the actual position in the buffer. That'll do it. That'll get us a position in the buffer. So in the image. So buffer put is going to do it that way round instead of doing it some other way round, I guess. Alright, what do I need in here? I'll need a byte. At least a byte. And it's going to be pixel shift 16. Alright, I'll take two opens then. Pixel P shift 16, and we have to do that strange thing, don't we, where and O X F F. It's 0 XFF. Close. Yeah. So we take the pixel out of pixels at that position. We then shift it over 16, that's 3, is it? Yeah, 3 positions. That's going to be our red position. I hope. If I'm getting this right. Yeah, red position, 16. Yeah, okay, I'm right. That's good. So we'll need 3 of them. Well, we'll need 4 of them. if has alpha do another one. That's 24. Sure of it. Yeah, 24. And that's the mask. Okay. But as I'm doing it the other way round, it shouldn't really be that way. Wait a minute. No. We're doing it last. Right, so yeah. I think this works. I'm not going to need that. There's no and there. That one's going to be 8. That's just going to be P. Will that work? Yeah. Because we're putting them straight in. Yeah. That'll work. Okay. Let's get my for loop sorted out. So, end of X loop. End of Y loop. Buffer dot flip. Get it ready for read. Should do it. Nearly. Okay. I want to do everything in the try catch. This is where I want to change it. We are going to need OpenGL in here. I'll use the window one. It's the easiest one to find. That one. Want it static, please, because we're doing OpenGL stuff. Yeah, it certainly does. So we could get ourselves a texture resource at that point because we've got the buffer. We haven't got the code. So we need to bind the texture. Yep, that's usually the first thing that we do. So GL bind we need an ID. Surely we need an ID. Oh, we need an ID. That's the ID. It's int ID equals GL gen textures. Oh god. No, it's not here. That'll do. Okay. Got an ID now. GL gen textures. That's that. We've now got a texture. Yay! Double check. Int equals GL. Yeah, we have now got a texture. Fantastic. Finally finished installing Visual Studio 19. Took forever. Yeah, it does if you've got a very slow internet. Well, if you've got a normal internet connection. I haven't. Luckily. Like I said, I'm not on the internet. So this thing goes... Actually, it doesn't go that fast. I think I get about 150. Megabytes per second. So it's not that big, really. I'm not going to ask them for any more. I mean, they're kind enough to give me this. So... Oh no, I've got this strange lighter thing here. Oh. That works. Yeah, it's one of those, isn't it? Yeah, that's how it's going to work, folks. Right, this is where I want to start changing stuff. Normally I do either GL linear, GL repeat or something like that. Well, I'm not doing that this time. I'm gonna try for a different one. So it's GL and then it's text parameter, and I want I, that one. I want the integer values of it. Right, so target is always going to be that. Always. What does it want next? It'll want the code for what I want to do. That one. In their infinite wisdom, they didn't use U and V. They used in OpenGL S and T. Yes, so it's just the XY coordinate by any other name. And this is where I want to do something different. I want to try that. I want to try clamp to edge instead of repeat, linear, or whatever. That might help us out. I know that you have to have that if you want to do a skybox. And that's a definite. If you don't use that parameter on the skybox textures, it's ook time. You get a crease, you get a seam right down the edge of your skybox, and you can see it, and it completely ruins the effect of, obviously. So if you do X, you've got to do the Y, which they call T, and I call V. I call them UV. I don't call them ST. What else can we have? We can do the floats as well, can't we? Actually, did I get these right last time? I don't think I did. Yeah, I put nearest. No min filter and max filter. Oh my god. I use G. They are not. They are Fs. I'm not going to change it. I'll leave that wrong. Well, I think it's wrong anyway. Let's see if I'm right. So if I do copy that, I want two more. I want minimum or minification and magnification. So it's that. It's GL texture. Min filter. Yeah. That's the one. And this one I want linear. Does blur it a bit, but that's not too bad. Yeah, that one. I think that's an F. Float param. doesn't tell us. Fine. Okay. I'm going to have mag. Oops, can't do it that way. The magnification filter. That's the one. We'll have that as linear. And now we can set the texture. So it's GL text image 2D. GL text image 2D. Variations we got. I'll choose the first one and see what happens. I think. Doesn't really matter, I don't think. Yeah, it gives me all of them anyway. So target is, as always, GL texture 2D, comma, level. Don't want any of that, so I'll put 0. It's an int level, isn't it? Yeah. I have messed about with it before. Doesn't seem to do much for me, so stuff it. Internal format. I normally just pick that one, but it is actually that one. So I'll have that. Width, image get width. Height, image get height. Border, none. Format. Good question. What format have I changed it into? Or do I want it to be? This is where you put GL underscore RGBA, comma. Type. It's a GL unsigned byte. That one. Buffer pixels. Should just be our buffer, but it isn't, is it? It is. Will it take a buffer as it is? It will. Done. Wow. I think we got it right. It's accepted. As long as it accepts that command, I think we have it right. There we go, catch. System out, no error. Print line. And it's going to be error, whoops, do it properly. Error failed to load texture plus file name. Yeah, that'll do. Return null. That needs to be changed. There we go. Looks good. That's a loader. Actually, we could just have it as a void, couldn't we? Yeah. Oh, I'm going to put it void. All right. Oh, one of my famous 99s. So I'll know it's me that's goofed it up. Okay. So that's a load image. Wow. Alright, what else will I need in here? Well, I need some public functions, I think. Might be helpful if we could get that ID. That ID is going to be a bit awkward otherwise. God, my notes are a mess. All right. So, public void bind int sampler. Position. We'll need to work that out in the render engine. GL active texture is GL underscore texture 0. Yeah. Plus sampler. It's just that I'm going to be using position 0 for the initial test. So that's why I stopped. What are you up to now, Muppet? Want to move? Hey? Want to move? You want to cuddle up? Oh dear. Ah, bless. It's been a good day today. Acorns finally took the plunge into Visual Studio 19. Ah, bless you. You'll never forgive yourself. That will set the active texture. And then of course we just need to bind it. And it'll be a target. GL underscore texture 2D comma, and then it's just M underscore ID. That's oops, capitalized. Yeah, I'll do it. Doesn't make sense to put it there, does it? Public void. Unbind. And that just takes in nothing. And that's just that. With a 0. So we can bind and unbind now. Public void get ID. And that's just return M underscore ID. Oops, not that one. That's it. That's better. Anything else I might need? Resources. Not got. Load texture. I don't think I want anything else in here. Nope. Nope, I don't think I do. Let's just have a look at these imports. Yeah, I thought so. I thought it had imported something I didn't want. So I've got the buffer utils. And image IO. We're not using aught. I've got the aught image buffered image. That's right. Why have we got Javax? Image IO. That's correct. I think. I'm just thinking it all through and make sure that I'm not cocking this up. Yeah, I think we're alright with this. Build. Let's see what I missed. Nothing it looks like. Let's have a look at some of these. To do. What's the green bit? Oh, that was that strange thing, wasn't it? Why are you green? Oh, you're not anymore. It's because I was... God, that's to-dos. Blues to-dos. Yellow. What yellows have we got? Not used. Not used. Not used. Not used. Field may be final. Don't know. Not used. Fantastic. We have a texture. Texture class without resource. That's it. Fantastic. That's what we did. That's what we'll have. Didn't have to do much. Quite pleased with that. Didn't have to write too much outside of the class. Which brings us to material. Yeah, it does. I'm quite proud that we kept it all within class on that one. Can't say the same for mesh. That was all over the goddamn place. Alright, to be determined. Because that's why the material class is here. But we just don't have any. I haven't even looked at resource systems. So, I think this is a resource, really. But let's see what I want. Let's think through this slowly, because I'm going to have to. I really am going to have to. In the past, loading a texture was simple. But now that I'm doing my own 3D engine, loading a texture is not that straightforward. We are going to have a variety of textures being loaded. A variety. A smorgasbord. Or whatever that word is. A feast. A feast of textures. Right. And also, we're going to have to start thinking about the shader, because that's what the material's all about. This is the material for the shader. The texture's just loads of texture. We're now going to start thinking about the shader, because that's coming up very shortly now. We're going to have to slot our shader in. And hopefully I've pre-written it. If I haven't, I'm an idiot. I bet I haven't. I haven't. I've got a basic shader in there, haven't I? Oh, God. That's a disaster. What the hell do I want? I want everything. I want absolutely everything. I can't write this without the material being extended. Right, so I have a way of getting a texture and a texture ID, that's all I need. This is going to have to wait. This links all the texture, well, it links the texture into the resource system so that we can delete textures on the fly. If you remember, Java don't delete, it's got a garbage collection system. Don't worry, we'll just override it. So this is actually going to be quite complicated, this. So currently all we have is the texture. I don't know how to keep trying that, it's dead. I think I might be able to set it up so it's easy to integrate. We could try that. At least get it started. It's going to need a hash map. It's the only way I can think of doing it. Yep. How about that? Right. Oh God. Normal map is a bump map. And we could also have a displacement height map. Displacement map. Get rid of that one. Spelling. It's fine. We'll need a way of storing them. Like that. And texture. Texture. A bit like that. So here we'll have that because it isn't implemented yet. We will then set our variables. Okay, that'll do that. And then we want the textures. The first one will be diffuse. And that will take in diffuse. Then we'll add a texture. It will be called normal map. And that will take in our normal map. And then lastly, very simply, we're just going to add texture. I'm going to call it disp map. Displacement. Disp map. This is going to make doing world maps easier. And that's going to be just disp map. That'll do. We could need a couple of floats for that displacement map, but I've got nowhere to put them. I won't be using it initially. Right, so who cares? Next. What have we got wrong here? Comma. Okay, we have to fill this in. It should be simple enough. M_texture. Texture, and that's going to be a put. And it's just going to be name. Name, comma, texture. And I'll do it. I'll do. Don't need anything else there, do I? At least we've started this thing, so if we've got an add texture, we should really have a get texture. Public. Texture, isn't it? Get texture. And I'll just take a string. Name. And it returns a value, so let me just put that in until I find out what the value is. Okay. Oh! Stretch. Oh, what do you want, Puds? There's food downstairs, put you some out. Yeah, there's kibble. I'll put you some kibble down. Go and get it. Go on. Kibble, cat. Go fetch. Go on, go fetch. Yeah. You want me to take you downstairs so you can eat? Bear with me 1 second whilst I show this cat where its food is. Come on. Come on, man. Come on. Hurry up. Come on, look. There we go. He's now quite happily eating. Eating his kibble. Right, so texture. Oh no. Won't do it, will it? No. We'll go with texture. Result equals m_texture map dot get name. That's all it takes. Right, we can't have a null return on this, can we? So If result is equal to null, system dot error dot print line error in material no texture found. And we can't continue on that error. If we try to, we've got a null result being passed back. So system dot exit 99. So it's me that's done it. Okay, otherwise we can return the result. Right, that'll do it. Can't return a null. I think I'll change that. I'll have to get a test PNG. I can make a test PNG quite easily, I hope. I haven't got one at the moment. I've got test objects, but no test PNGs. That'll do. Yeah. We do need some floating point values to decide how to make that height map work. And we will need some kind of lighting information. At the moment we're only going to have one texture. So what can we have? This is going to be awkward. We'll see when we get to it. It's all about the shaders. All about the shaders. Never used. Maybe final, I don't know yet. Never used. Okay. I don't decide on finals until I've got the final version. Wonder why that is. That is the basic material class. Very basic. Hasn't got half the stuff in it that it needs, or should I say it's only got a fraction complete, but we can add a texture and get a texture from it. Does it load the texture? No, it doesn't. Alright. As long as we can put a texture in and it's public, that means I can use it. That'll be good. So we have material. Okay, let's go down the list now. Index done, OBJ done, material sort of done, mesh done, render engine not even thought about it, texture done, vertex possibly done, window 3D just the one off the website for LWJGL. If you go to the website and see getting started, that's all I've got for my window 3D, except I've taken, I'll show you how to take the window output, the window input out of it. On the website, it has the callback inside here in the window 3D. Instead, all I've done is default window hints, version major 4, -6, window hint, core profile, visible faults, resizable true. Those are the two that you get. Should put that to resizable faults. You create the window. This is just what it's got on the website. If it's null, failed to create window, yeah. Then I set the key callback using window, comma, new window 3D input. And then I've created a separate file called window input, which overrides the invoking of that callback. So extends GLF key callback. Then it takes in a bit of stuff, it decides the keys. That's bad. That's bad. I'm getting 2 per press. So I'm getting the press and the release at the moment. Or press and repeat is very, very quick. I don't know which one I'm getting. But every time I press a key, I get two things coming through here. But if the escape key is pressed, GLFW should close, window true, and that gets you out of the main loop in the game, the base game, core base game. Sorry, the core engine will come out of its loop from that using escape key on the keyboard. But of course we're going to need more. I don't know how that's going to work yet, because we need the mouse as well. I'll do input when I get to it. So that's your window. Get your video mode. Assert that it's not null. Set your window position. Make your current context. Tell everything else that OpenGL capabilities have been created and we can share them. That's a special function. And after that you can use OpenGL commands. But you can't use OpenGL commands until you have placed that in. Then we can use the OpenGL commands to enable things like depth test, color face, blending, the blending type, the background clear color, which I've set pretty high at the moment. What clear color is that? Purple. That's a bit more blue than purple. That's good. That's all I wanted. We can set our swap interval. It's supposed to enable VSync, but I don't know whether it does. Yeah. I suppose I could set it to 0 and find out. No, still at 60. But I think we're self-restricting to 60 anyway. So I think we're taking it from 2 angles there. And then show the window. Check the display is open. Update the display, swap the buffers, poly events. That's your keyboard. Close the display is just terminate and destroy. And set a, and it, well, I didn't even set the errors callback, but hey ho, just in case. We've got that in there. That's it, that's material. There we go. Right. I want to check vertex. Is that all I need? Notes. We've got get tangent, set tangent, yeah. Yeah, can't think of anything we want in there. Java overview. No, I don't want that, thank you. So I think we're alright there. Is there anything else we can put in here? There's a shader. Render engine and shader. Is there anything else I had down here? Got. Not got. Not got. Texture vertex window input. We're actually on render engine and shader. Wow. And then we have enough to create the core or start working towards using all of this. That's bloody amazing. I'm only going to have one shader. Decided. But we'll use components, so that'll change it. Okay, shader. Yeah. Again. Right, that's the first thing. Guess what I'm going to have for this thing? How's about a file name? I think that's okay. God, this is getting easier. I must admit, as it's gone on, it's got easier. Because I've got more and more filled in. I've got more and more available to me. It's starting to become a little tad easier. And all we need to do then is reset that variable to a member variable. And that should do it. All right. May as well. Vertex shader text. I'm just going to put a semicolon there. What's wrong with the word vertex? It's not got an R in it. Fragment. There's a million and one ways you can do this. Seriously, there really is. Oh well. Let's see, what's the first one we're going to need? Load shader, I bet. Probably. Oh, God. Oh, God. Just one sec. I'm going to do it all in one. No idea how I'm going to do all of this. Let's see if we can get the basics up and running, shall we? Yeah. That will be static if it's private. I've just got it load shader. And it will take in a string. File name. That's all I need, isn't it? Is it now? So I can work out what I'm doing. All right. All right, I think I know what I'm doing. I just think I know what I want to do. Yeah. So that is going to equal and it's going to be file name, and it's dot shader, isn't it, in this language? Yeah. I'll have to change it. I think the other variation is VSH. Yeah, because those have two different names, and I need a file name system that gives me same file name. Alright, I'll have that then. So in here, I can delete these two. These aren't the ones, are they? No, these are the crappy ones. Delete. Okay. Delete. Okay. New. Name. Blades. And it puts .glsl on it. Okay, version 120. Alright, that's what we'll use then. I'll use whatever version you give me. Blades. And this time we're going to have FSH. FSH. There we go. That means I shouldn't forget now. VSH. Yep, that's good. Equals load. It's how it knows which one it is that we're loading. And it's going to be file name. Plus .fsh. That's all I need, as long as I know, because I know completely that's a fragment shader and that's a vertex shader, but I want them both to have the same name, just different extensions, so I can use it like this, which is a lot simpler. So when the string comes through, it doesn't matter which one it is. All I want this is the text. So all I'm going to do is pull in the text, but I'm going to parse it as well. And it's going to be a ludicrously massive parse. Oh boy. Should we write the shaders first or try loading them first? Don't even know. I don't even know if I've got shaders for this. I'll have to look them up. Bugger. I'm going to have to write myself some shaders. Oh well, I suppose we start this without even knowing what the shaders look like. I know what they look like. I've got a good memory of them. And they're huge. As you are about to find out. At this point, I might struggle with my blank memory box, because I've got to try and keep it as blank as possible. This might hurt. So I'm going to have to rely on my notes and just go with that. Not think about the shaders at all. I know what the final shaders are, but I better not think about them on the way. Otherwise I could get into trouble here with my head. And if I do, I'll be offline for a few days with a migraine. And a lot of pain. But I've got the painkillers ready, so I don't care. Alright. Chill out, relax. How are you lot doing? Oh well, Akron's off playing with his Visual Studio in 2019 now, I bet. He's going to be very disappointed when Visual Studio 2021 comes out. I do think it's funny. They keep updating it and making it worse. The more general it gets, the worse it gets. I have an i7 processor available to me that can't keep IntelliSense going. We're talking like 12 threads, 6 cores, is it? 6 cores. And IntelliSense still fails. When I get to a program of this size and structure, IntelliSense totally fails. This hasn't failed once. And this is just a free piece of software, Community Edition. Just like the VS Studio. It's rubbish, Visual Studio. Problem is, the IntelliSense, they use the same bloody one in Visual Studio Code. And as soon as I get to this size files, number of files, Visual Studio Code starts buggering up as well. So it must be something in with their IntelliSense that's just so wrong. This IntelliSense is coping with all of my libraries that I've added, like lots for LWJGL. I've added all the libraries, and it's coping with all the Java stuff, okay, which is a hell of a lot. Plus, it's running a server to run the program on. Plus, it's running an interpreter and using these as scripts. It should be as slow as hell. Really? But watch. Can I? Here we go. Build. I don't know if there's going to be errors in this. Rebuild project. Build completed successfully in 2 seconds. Low milliseconds. I don't think it takes that. I think it would take a bit longer on Visual Studio. If it takes more than 10 seconds to build a project, there's something wrong. We're talking about big projects. We're not talking about diddy things. This is a fully functional 3D engine that I'm building. And this is going to be a huge file for the shader. Where shall we start? We'll start by making a resource note, I think. Most likely. Oh dear. Let's see if I can find some notes on this. It's huge. I didn't know that Java had structs. God, I'm stupid. I just assumed it didn't have them. Because of the pointer problems that it would have. Thinky. How's this going to work? I don't know. All right. I'm just going to go for it and see what happens. String builder. Call it that. Hello. Let's have a shader source. We'll need a buffered reader of some kind. Not image this time, a reader. There you go, shader reader. Don't know. And I'm going to do something remarkable. Otherwise my shade is going to be very hard to write. Yep. Shader language GLSL does not have hash include. It does now. That's just made it into C. And if the C compiler can do it, so can we. Oh god, it's going to give us another try catch. This time I will take the file reader, I think. Can't see why not. Well, that's the one it tells me to take anyway. So it's res slash glsl slash and that's got the VSH and FSH already added. And that's that. And of course, we have the red squigglies. Bing! Okay. That gets rid of the red squigglies. Easy enough stuff, we've seen this before, I think. Is not equal to null. Standard setup. You're joking me. Please, you are joking me. We're already in a try catch. Okay, we'll do that then. I don't care. I don't care what it wants to catch. Particularly. I would like more information out of it though. System dot out dot print line. We'll have that. And I'll also have, I wish I could type, exit 99. That's better, I'm happier with that now. While the shader is reading lines. Got to make this recursive. If line starts with nothing we used to use, include directive. Oh, then we better do something about it. Shader source dot append damn it. Thank you. Oh god, what are we going to append? If we hit an include, a hash include, what are we going to do? This is going to be a hell of a command. Load shader. Now we need the substring. So that's line dot substring. I want the second one there. Beginning is include directive dot length +2 for the spaces and stuff, comma. There is an error with this. There has to be a space between hash include and the name of whatever you're including, I suppose. Because normally that's put in inverted commas, so it's +2. We'll do line dot length to the end of the line. I think that'll do it. I think that should get us a hash include. But there's a return, there's a null. So -1. Yeah, that's better. Hell of an if statement. Hell of an if statement. I bet you're glad I didn't write that one across the screen. Else shader source dot append we should put those semicolons in. Line It's not good enough. Dot append. \n. Have to put that in. Yeah. That's the while loop. It's done. Don't need any more. Well, there's an interesting piece of code for you. We append another file. On a hash include, which is exactly how, well, the compiler doesn't quite do it that way because it doesn't have this +2 limitation. It actually searches for a file name through the string, but I'm not doing that. That's too in-depth. Simple way of doing it's easier. So we'll use a simple way. What that means is I can hash include other files into here, into these two. Yeah. Ain't that nice? Did I mention it was going to be a huge shader? Alright, so now we're out of the while loop. Close that down. Okay, catch the exception. Yeah. Shader source. ToString. That's it. Done. We can now load shaders. That's your basic shader loader anyway. The only reason why it's in a method and not in the main is because I wanted to add this hash include. Right. So we've loaded the shader strings. 2 strings we've got now. Let's go back to our main. What do we want to do with those? We want to actually look through them and get all the information out of them that they hold. And I mean all of the information out of them. So we're going to need a program. An OpenGL program. Okay. Probably going to be private again. Oh, we're going to use the geometry shader this time round. Could do. We'll need to start with the program though. Yeah. Alright, I've got a load shader. So I've got that far. Next part, we need to start thinking about adding those shaders to the program. That will involve the private. Oops, that's a capital P, doesn't like that. Private. It'll be a void. Add program. And that will take a string of text. And whatever type it is. So we've got that. Okay, let's build that up a bit more. What kind of things do we want to add? Let's have a private void add vertex shader, and that's just going to take in string text. That's just going to point onwards to add program text, comma, whoa, stop. OpenGL 4.6, please. I'm always taking it from here, so I know that I'm not going to make copy-paste errors. This is the basics of that. There we go. That gives me access. Text, and it's going to be a vertex shader. Hope it's here. Yes, there it is. That's it. Don't have to use it. Oh, go on, sod it, I'll put it in. Can't see what I'm doing. Add geomet3. Is that how you spell it? I think so. Geomet. That one. So we can have geometry shaders. Fragment shaders. You can have anything you want. You can expand this as far as you want. Whatever kind of blooming shaders you can think of. That one there. Fragment shader. So that will allow us now to add those to an OpenGL program with a bit of luck. Which is what I want to do here. What is it doing that for? don't know if I'm going to do a geometry shader though. Probably will for water. Alright. And that's just going to be vertex shader text. Add fragment shader. That's just going to be fragment shader. You can see how easy this is now. You're just creating your own language in which to do it. That's it. Yep. Done. Okay. Add program. Here we go. Can I not get any further down? Right. Okay. Thank you. So that's what we're doing. This is where we are up to. We are going to add each of the shaders to the OpenGL program. Dead easy, you say. So easy it should be. You can do this blindfolded. Not. God, there's way too much code. Alright, add program. Need a quick bio before I tackle this one. Might need more than that. I might need a new brain. What time are we on? God, 20 past 4. Needed that. Oh, a little respite. Right, so adding programs. Normally you just say create GL program, OpenGL, add shader, dead easy. That's exactly what we're going to do. If Muppet survives his coughing fit. You're right, Muppet. Oh, he's furballing, that's fine. Okay, add program. Quite simple, straightforward. Int shader equals GL create shader. And we want the type to be type. We decided on that. That's why we needed the types. If shader is equal to 0, then we better say something about it, I think. Yeah. System error print line It's error. Unable to create shader. Add program stage. Just so I know where it is. Because guess what? Oh, wait a minute. Do we want to put text and rubbish out? Doubt it. No, that'll do. Yeah, we'll exit it. Can't continue, otherwise it'll get very upset at us. There we go. That'll do. So, the GL shader source. Don't know which one I want. So, we've done shaders before, haven't we? I'm sure I've covered shaders before. Yeah, it's just shader. Takes in the number, doesn't it? Comma. Text. Okay. I think that's right. Yeah, it is. This is straightforward, this really. Let's compile it. Shader. Now let's do the silly things that we always should do when you compile. When you compile something, check. So, if, and who holds it? It's GL shader I. GL get shader I. Yeah, that holds it. Shader. We'll have GL com. Is it GL compile status? Yeah. Compile status. Yeah. If that is equal to 0, then it's all gone wrong. Most likely. System dot error dot print line. What do we want to print? Well, we want to print the error. That's for starters. It's in the info logs, isn't it? Okay, GL get shader info log. That one. For the shader and an arbitrary size. I don't really care how big. Just make it 1 kilobyte max. So we'll print that out. Yep, that's right. And then we'll just do a system exit. And this time, it's a 1. It's not mine. It's theirs. I'm not in control of that one. That's coming from your graphics card. Whatever that message is, it'll tell you what you need to know. I've tested it out. It works perfectly. Okay, I'm happy with that. Alright, so checked the compile. Which means we can now do the final part, which we haven't got. I'm guessing it's just an int. So a private int m underscore shader program. That's what I'll have. This dot m underscore program shader program equals gl create program. That'll do. Because without it, we're stuck. Because in here, I want to put in gl attach. And for that, you need m underscore program. Whoops, just stop. Dink. M underscore program. Shader program. And of course the shader, which you just compiled. And that should do it. That was a bit of a groan there. Muppet, are you alright? Oh, you just didn't enjoy having a furball moment. Okay. And that's it. Done. So we can load the shader and we can add the shader to a shader program. That sounds fair. But there are problems ahead. Oh boy, are there problems ahead. Okay. We'll just have to take this one step at a time, I think. And work our way through it. And I've got to look at or think about the shader itself. Interesting. I might just write it out by hand first. Try and get it sorted out that way. Yeah. You see, we can't compile the shader even though we now have the full program. Because in OpenGL land, the only time when you can detect all of the attributes in a shader is at this point now. Uniforms we can do after the compile, but attributes for the vertex shader we need now. Right, so let's detail some more of this in. Add all attributes, and it's going to probably be vertex shader text. It's probably going to be something like that. Then, and only then, can we compile. A shader. Next, we will want to add all uniforms. Anybody who's been through the shader stuff with me knows what attributes are, knows what uniforms are. Attributes are per calculation. Uniforms are for the whole of the vertex or the model. Yeah, uniforms govern the whole model. Or the whole thing. So they get set once per render, whereas the attributes are set for each vertex in that render. And are variables, where uniforms aren't. They're more like constants. That's a better way of putting it. I'll have to go with vertex shader text. We'll have to parse that for it. But we'll also have to do it for the other one as well. At this point. I'll have to do it twice. New fragment shader text. Otherwise, it won't work. We don't have shader resources. And that will be it to do. Add a shader to resource system. Because we've finally got one, by the way, at this point. And that's it. That's all we need to do. That'll do it. So it looks like we've only got 3 more methods to write, but that's going to split down into a snowball effect. Right, so there aren't any public methods I want. Yeah. Public. Let's put these in. What time are we on? Yeah, it's just I'm running out of time and I'm trying to do as much as I can and leave myself enough notes to be able to carry it on. Bind. And that is GL use program M underscore shader program. That one's an easy one. Anything else we might need? Do we need to unbind a shader program? Not really. We will need public Void. We'll need an update, I think. We usually need an update or something for these things. Update uniforms. Don't know what's going to be in there. No idea. Right. What else will we need? Nothing, I think. No, nothing. We're going to need those, aren't we? So what have we got here? Add all attributes. Alright. I'm going to use a hash table for attributes or uniforms. Uniforms, okay. So we're going to have an add all uniforms and a find uniforms, most likely. And we are going to generate a hash map for that. Right, okay, and we're going to split that down into different things. And otherwise, we're done. Sugar. No, we're not. We'll have to have some more bits and pieces like set attribute location. I'm going to be using a VAO. That's awkward. We might have to have a public get attribute location. Or make that public. Oh dear. Maybe we can put that into that updates. Let's see how that works out, because I've got to be very careful, because I have to have a VAO running to record this. Which means I'm just going to have to store everything. This is going to become a massive storage class. But otherwise, yeah, I think we're nearly there with what we've got. We're going to need some more helper functions, though, at some point to make it all work. And a load of setters, as usual, for matrices 3F, 1F, and 1I to set the uniforms. Those will all be public. Yeah. Okay, I'm happy. I'm actually quite happy with that. I think we've got quite a way into shader, which I wasn't expecting today. Do the commit. Why have I got shader.java? Where's that come from? Oh yeah, I know now. Grief. to parse for attributes and complete the update plus public setters. For uniforms. Yeah, that'll do. 1 added, 2 deleted. Good start. Wow. Let's see how big this is getting now. Oh, we haven't added that much. We're only up to 21 to-dos and 10 files. That's not bad. I'm going to have to start work on the shaders. So that's what I'm going to do after tea. And in the meantime, I hope that you all have yourselves good tea. Because I'm off to feed the cats in a bit. And I just want to chill out for 15 minutes before I do that, instead of having to rush for it like I did on Sunday. Yeah, we've got a lot further than I expected. We've nearly got a rendering, well, the base rendering system done. I think the shader's going to take a lot more than I expected, because not only have I got to write the code for reading and parsing it, I should really have the shader code to refer to, and I haven't. So that's where I'm up to. And I put those hash includes in on purpose because I'm going well, not might, but I will want to use those as well. This could be interesting. This could be very, very interesting. So I'm going to let you all get off. If you want to join me tomorrow, I'll be on again, probably more in the afternoon, as I want to continue this shader business and see if I can come up with some shaders. If I can, then we are rocking and rolling into the first major test, instead of just being able to put a triangle on the screen, which was what I had to do yesterday, just to make sure the system would work. Otherwise, I'm hopeful now. I am very hopeful that we've got it. The first test object actually splattered something on the screen after I altered the way the graphics card used the information. Otherwise, I think we did good. We did good. If anybody wants to have their say in any of how this works, please feel free to do so. I find most of it baffling, and I design half of this sugar stuff. I've been sat down messing about trying to make sure everything fits together, and it does. It fits together at the end, just like a jigsaw puzzle. It's quite nice. And bloody fast. Even though there's going to be a ton of code. So, yeah, in the meantime, I want you all to take care. I want you all to stay safe. I don't want anybody out there getting ill. And if you can, have a bit of fun. And I might just look into that Unreal API as well, just for a laugh. See what there is on it. But I want to look at shaders first. Right. That's me out and the cat scriking already. Fantastic. Take care, peeps. And I think I've already found a stop button, so good luck.